the axis is going to be this, and this we haven't done it yet, but the greater tuberosity. All right, so greater tuberosity in anatomical, they said it's easier found in external rotation. So you will feel it. So it's not, here is the acromion process, okay? And you can almost feel it if I put it on. See that thing rolling under my thumb, back and forth there? That's greater tuberosity. So in this position, it's going to be right there. So that would be where the axis would go. Okay? All right, so if I put the axis there, all right, then we're going to be parallel with the midline of the thorax. And so when you're doing this, what I want you to do is, see here, there's a little arch to the back. What I'd like to do is bend both knees up, feet flat on the table. That's fine. and see how it flattens the arch out and back. Now it's a little easier to keep along with the midline of the thorax. Okay, so now it's going to say we're going to be to the lateral epicondyle up until 90 degrees. So go up to about 90 degrees for me. All right, and so there's the lateral epicondyle of the humerus. I've got my axis there. She's not quite at 90. All right, what's that? So what I've got there, keep going, there's 90. Okay, so there's 90 there. And I've still got her lateral epicondyle. But now go all the way up as far as you can. Or what happened? Okay? There's the lateral epicondyle. I can't put my stationary arm. However, because of the rotation, the olecranon is pointing right at. So I can get on the olecranon, but now I've also lost that greater tuberosity because that's rolled under the table too. So I just got to imagine that it's still there, and that I'm still parallel with this. And now I can measure, and she has about 178, because she's probably hitting the hand resting on the table, 178 degrees of overhead flexion. But that would be, remember how the knee, we were able to see our landmarks whether we were flexed or extended. And so here, what's going to happen here is, you can see this is fairly flat here, got our lateral epicondyle visible, our greater tuberosity visible, but if I put my finger on it, look where it goes. My thumb is now, it's now underneath. And now, this is now underneath. So they both rotate together, so they both disappear, and so now you've got to imagine that it's still there, okay? You're going to go here, and now see we've got that arch in the back because we're really up. So you've got to make sure you're not following the arch of their back. You're still trying to keep midline through the thorax or fairly parallel with the table. Don't say parallel with the table, that's not the right side. But if you started off parallel with the table because your knees were flexed and you were flat, you should still be parallel with the table up here. One of those math different things. So that's where this one gets to be a little tricky when you're measuring it. And let's go wait, I got you good. Now, abduction is we're going to measure that motion that comes out. Okay, it comes out that way there. So this is now, remember this was the lateral epicondyle. This is the medial epicondyle, and what can be confusing is it looks like that can't be the medial epicondyle because that's the thumb, and so that's got to be the radial side. But remember, pronation, supination is coming below the elbow, okay, from the forearm radial ulnar joint. So this is still the medial epicondyle. If you don't believe it, tap there, and you can always tap and find out where it goes. It's not going to go out toward the thumb, it's going to go out toward the finger. So, but here it says that we're going to go parallel with the sternum, and we're on the acromion process. So now you can see where the round part of the shoulder is, and now we're going to be not where that was rolling, but up on the bony part, right there, the acromion process. But, okay, so watch what happens as she goes, well, if I was on the acromion process, it's not there anymore. Okay, I can't have my goniometer behind her on the table. So you just have to imagine where it would be, right through there. So now, you know, that's why I say, especially when you get to the shoulder, it is really follow things through a range of motion. Measure them at the end. If you try to follow shoulder motions through their motions, it drives you crazy. Okay? So, what we're going to do here is imagine that it was there, parallel with the sternum. Put this over so I can read the numbers the right way. And we have about 170 degrees. So she's in the normal range, almost textbook. Okay? Now scoot over that way just. Good. I'm going to use your shirt. Okay. Too far. Okay, so internal and external rotation. You're going to notice that they used a prop, and that prop was a towel. Okay? And it's kind of the same thing we did for elbow flexion extension, because if you look here, where's the olecranon compared to the glenohumeral joint? It's downhill. Okay, so what we want to do is try to make that a little bit more parallel. Again, don't stick it underneath the scapula, but it's going to be more parallel. So you'll be lining up here, as you can see that way, and this will be, and this is how you can tell. Watch your shoulder. And this is what's tough. You got to make sure that olecranon stays lined up with the glenoid. Feel it right there. See your shoulder. Watch your shoulder blade. You'll feel it. See it start to roll and lift off the table. That's at the point where the shoulder complex is coming in. Glenohumeral motion is stopped. So what I would do is I would find that place where the shoulder blades start to roll up, and just kind of keep backing up till I can say, okay, that's where it first stops, and that's where I'm going to measure. Okay, because we could go, if we went down farther that way, it's the shoulder blade coming. It's not really the shoulder rotating anymore, so that's scapulothoracic motion. And external rotation, what I'm going to do is go this way, and what you have to do is you have to kind of feel it's going to go the other way. And you feel right at the point where the shoulder, the scapula starts to go in and down into your hand. And you'll have to kind of identify that, and I can almost tell by the eye that she's got about 90 to maybe 95 degrees of external rotation. Now we can go farther than that, but you can see that the whole scapula is starting to rotate up that way. So that's scapulothoracic motion. So that's the only thing you're going to have to define. And a lot of times too, if you don't do this, if you just start going there, see what's happening? Okay, her arm's adducted. So you've got to, this is what's called the 90-90 position. 90 degrees of elbow flexion, 90 degrees of abduction. So we've got to maintain that position, and that's where we'll get true glenohumeral internal external rotation. If you allow it, usually if you don't stabilize it, you'll get further abduction with this, and going in internal rotation, it'll start sweeping down into adduction. So, that's the tricky part of this, is getting the good stabilization, identifying. It'll be a lot easier usually to identify where the internal rotation stops, because you'll see the shoulder blade start popping up towards you. You got to get on the back side and kind of feel. And you'll feel it. You'll start to get a feel. There's that end feel thing where you'll feel it like there's a point where it goes smooth, 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 and stops. And then you have to push it to go farther. And if you let go, it kind of pops back up to where that smooth motion stops. So those will be the different rotations that we measure. So that's what makes the shoulder much more complex, is because you have disappearing landmarks from where your anatomical reference position is. You have to maintain proper positions, have to be able to identify where the scapula starts to contribute to it for rotations. Okay? So those will be the fun things we'll be doing over the next couple hours, but what we're going to do is mark on each other first. So make sure you got get yourself ready for lab, get your pens and marking material.